Risk and return of portfolios. The last chapter was all about the risk and return of single assets. Can anyone tell me what a portfolio is? Yeah, so it's basically the collection of all of our assets, right? All of your investments. Okay, so we're looking at more than one. And it turns out that when we look at portfolios, you can't just say, well, the behavior of the portfolio is probably just mimics the weighted average of the things inside of it. That's true for some things and not for others. So now we're going to have to throw some more complex mathematics into it. We still remember that central value of the normal distribution. We've been using the arithmetic mean for that. We're going to replace that terminology with the expected return. And so the historical average is the expected return using sample data, but we're going to go a little bit beyond that here. Now, let's talk about how expected returns are calculated. It has to do with probabilities. So there's a 25% return, the 25% chance that return is going to be this. There's a 25% chance it's going to be this, and there's a 50% chance that it's going to be this. So we say 0.25 times the first return, 0.25 times the second return, 0.5 times the third return, and we add them together. And that gives us our expected return. Now, what does this expected mean in statistics? It is our very best guess. Is it a guarantee? No. In fact, I'm going to teach you an industry term today. That term is SWAG. SWAG is an acronym. Now, you guys probably been watching the Oscars after parties or whatever, and they talk about the swag bags, and then they say swag stands for stuff we all get, which isn't true because I don't remember getting one of those bags, right? Because I think I'm part of all. Now, here in this case, what it means is scientific wild ass guess. Now, some of you hear the word ass and you, we're talking about a donkey here. Get your mind out of the gutter. So a wild ass, their movements are unpredictable, right? You could have a wild ass guess about anything. I could say, what's the S&P going to be at the end of next year? And you might just throw out a number. That would just be a wild ass guess. But if I arrived at it by looking at the different scenarios and the different probabilities of those scenarios and then coming up with an expected value, that would go from being a wag to being a swag. Does that make sense? So expected values are scientific wild ass guesses. This morning I got up and I asked, what is the high temperature going to be for today? And I forget what lie she told me, but you know, it's the Alexa or whatever. I forget what lie she told me. Now, I say what lie she told me. Does she know? No, what's she throwing at me? That forecast is a swag, right? It's a scientific wild ass guess. It's an expected value. Is it a guarantee? Absolutely not. So that's why we call this median value, or not median, the middle value, the tent pole of the normal distribution. We call that the expected return. And we've got return variance and standard deviation, which we talked about in the last chapter. We talked about them, though, on a sample basis. This time we're going to be using some population statistics. But now that we're looking at having these portfolios of different items together, we have to start wondering about how they move together. So, are you ready for my sweet interpretive dance moves? So here we go. What if we have two items that move together? So we've got stock A and stock B, and we've got these two items that are moving together. If we add those, we've got 50% of each one of those. Put them together. The portfolio is going to look a lot like that. It's going to have similar returns. It's going to have similar risk. But what if instead I had two items that were moving differently? What if my items were doing more like this? When I add those two things together in a single portfolio, Now it looks more like this. And so I'm still getting the weighted average of the returns on those things, but I'm not getting all that jumping up and down. And what did we say the jumping up and down of a value is? It starts with an R. Risk. It's risk. And so now it's starting to matter not just what the returns and standard deviations of these individual things are, it also matters how they move with respect to each other. And that's where we get these new terms, covariance and correlation. Covariance and correlation. And we're going to see that, she's lost me again. Okay, we're going to see that these things are both measures of how things move with respect to each other. But they're similar to standard deviation and variance in that one of them's a whole lot easier to interpret than the other. Questions so far? Okay, here we go. Now we've got double trouble. Remember previously we only had one stock. Now we've got two. We're going to take it easy on you. We've got two. We have SuperTech. The expected return is 15%, which we will calculate. They didn't even have to give it to you. In fact, we'll calculate and prove that to you. And we've got Slowpoke. And I want you to notice something here. We have 4 states of the economy. Now, some of these problems we'll talk about 2 states, some of it, well, 3, some 4. You know, so we got different states of the economy here. Just you got to look before you start on the problem to figure it out. The next thing I can tell you is that when you add the probabilities of each state of the economy together, they must equal a certain number. What's that number? 1. When you add all the probabilities together, they must equal 1. And so here what we have are depression, recession, normal, and boom. And there's a 10% chance of depression. There's a 20% chance of recession. There's a 50% chance of normal time and a 20% chance of boom. What's boom? Yeah, better than normal, right? That's a boom. And then we do have a scientific definition of recession, and that is 2 or more quarters, consecutive quarters, of negative GDP growth, gross domestic product. And so if the economy shrinks for more than 1 quarter in a row, that's a recession. Now, we do not have a scientific definition for depression. I can tell you this, every depression has recession in it, right? Because it had at least 2 quarters of negative GDP growth, but there's also an emotional kind of thing that goes along with it, and we know that it's worse than a recession. One time, Ronald Reagan was asked to define the difference between a recession and a depression, and he said, a recession is when my neighbor loses his job. A depression is when I lose my job. So it comes to it's the emotional state, right? And if you look back to when's the last depression we had in this country? Yeah, the Great Depression, and it was in the 1930s, right? Okay, do you know that before the Federal Reserve Bank was founded, we had those kinds of things like frequently? And so now we think of a Great Depression, or of the Depression being a rare thing. It used to be a fairly common thing. So we as a human race are doing a little better than we used to. Okay, now, hopefully depression is the least likely of these, and they give it a 10% chance, recession a 20% chance, normal 50%, and boom 20. Now, the next thing I want you to notice is how these stocks react differently to the different states of the economy. So if we look at SuperTech, in depression it's down 30%, in a recession it's down 10%, in a normal it's up 20%, and in a boom time it's up 50%. We would call that a luxury or normal good. So you may hear it 1 or 2 ways, but the idea is this: when the economy is growing, people are buying more of it. When the economy is in bad shape, the people are doing less of it. So let me give you an example. BMW. BMW would look like this. During boom times, people are buying lots of it. During depressions, people aren't buying as many. Even if you can afford to buy a nice car during a recession or a depression, you may not do so simply because of the people around you. Example, during the financial crisis, I was like moments away from putting my signature to buy an Audi A4. And then I ran into my neighbor Larry from across the street. It's Larry and his wife, and they've got this new dog. And Larry's just lost his job. Remember, it's a recession, not a depression. So my neighbor's lost his job. This is a true story, by the way. And we're like, oh, what a cute, fluffy puppy. We're petting the dog. And I said, what's his name? And his wife says the dog's name is Audi. I said, Audi? I said, like the car? And she said, yeah. I said, why? She says, because it's the car we've always wanted, but now we know we can never afford. Do you think I bought an Audi? No. I bought a Nissan Altima, and I drove around like a kindergarten teacher for a couple of years, right? Okay. Because that's the kindergarten teacher car, the Nissan Altima. In case you guys weren't in with the kindergarten teacher crowd. Okay, so you can see that those kind of goods the sales are going to be way down in bad times. Now, and another one, how about craft beer? Craft beer. During good times, there you are with your friends and you're sitting around talking about your fancy IPAs and whatever it is that you drink. Do you think people do that during bad times? No. So those craft beers are not going to get near as much action in those times. Now let's look at Slowpoke. And in depression, the return is 0. And you might think 0 is a bad return, but 0 as a return in depression is great, right? And then as you move on up, things improve right up until you get to boom time, and then it's actually down. So this is somewhat what we would call an inferior good. And it's a good that their product is a good that people would consume more of in perhaps the bad times than they would in good times. Cheap beer, cheap liquor in general is an inferior good. Remember I just talked about craft beer being a luxury good. What's going to happen to sales of Milwaukee's Beast as the economy goes in the tank? It's actually going to go up for 2 reasons. Number 1, people are replacing their craft beer with cheap beer. And number 2, people actually drink more in recessions. Why do you think that is? This thing keeps looking away from me. People actually drink more in recessions than they do otherwise. Why do you think that is? Stress. They're drinking to forget their troubles, right? I'm not recommending that. That's just what people do, right? And if you look at Russia, 1998, when everything fell apart over there, vodka just took off. And not Grey Goose. It was like, the really bad stuff. Okay. So that's why we might see these 2 different sets of returns based on the same exact economy. And so that's where we'll start up next time. Are there any questions? We were right here, and we were talking about SuperTech and Slowpoke, and we'd identified that these are 2 different stocks, but they're operating in the same economy. And we talked about the different states of the economy, which were depression, recession, normal, and boom. And what did we say about the probabilities of all those states added together? What does that have to be? Yeah, it's got to be 1 or it's not going to work out. And we'd already talked about the different rates of return in each of these scenarios. And so what we need to do now is figure out the expected return. They give it to us here, but you won't always be given it, but you can always calculate it. And so that's what we're going to do right now. And I want you to look here on the board. Does anyone feel intimidated by this formula? Yeah, just because it has a Greek letter in it, people start to lose their minds. But let me walk it through with you. So what we're talking about is the expected return on stock A. Now remember we said an expected return was our best guess, also known as a swag. What does swag stand for? Scientific wild what?
Wild ass guess.
Very good, wild ass guess. You need to, if you're going to deal with donkeys, you've got to learn the word ass, right? So stop freaking out, people. Okay, so scientific wild ass guess. Now, it's like the weather forecast, which by the way looks really bad. So, what do we got here? Can anyone tell me what this thing is? Sum. And it's sum from 1 to n. In this case, this thing is operating over the different states of the economy. Can anybody tell me what n is going to be in our situation? How many states of the economy do we have? 4, right? So it's going to be from 1 to 4 in this situation. And then this is the return on stock A given the state of the economy. And so for the first one, it would be negative 0.3. And then we're going to multiply that by the probability of that state of the economy. What's the probability of depression? 0.1. And so what we're going to do is negative 0.3 times 0.1 plus negative 0.1 times, anybody? 0.2. Very good. Thank you, Ms. Hepp. And then 0.2 times 0.5 and 0.5 times 0.2. And we're going to add all that together to get our expected return. Now, I'm going to go ahead and work through that first one so you can actually see it being done. So here we go. What's the probability, or what's the return in the first state? Minus 0.30 times the probability, which is 0.10, plus minus 0.10 times 0.20 plus 0.50 times 0.20 plus 0.20 times 0.50. Did I get those mixed up as far as, yeah, the returns and the probabilities? So this is actually the third state and this is the fourth state. Let me go ahead and fix that so your notes will be correct. There we go. Does that look better? Some of you say, I don't know. So you can go back and watch this later and see what we did. So basically, this is the return in the scenario times the probability of the scenario. Return in the scenario times the probability of the scenario. Return in the scenario times the probability of the scenario. Return in the scenario times the probability of the scenario. So let's go ahead and do the math. So we've got negative 0.3 times 0.10, so that's negative 0.03. If you don't believe me, go ahead and do the math on your calculator. And then this next one will be minus 0.02. And then it's going to be plus 0.10 plus 0.10. Have I made any mistakes? Okay, when we add all that together, we get 0.15 or 15%, which by the way is what they told us it was to begin with. But once again, I won't always give you the expected return, but you can always calculate it for yourself. Now, do we need to do this also for stock B? Would you like to see me go through that one with you? Okay, Ms. Herdman says yes, so we're going to do it. Okay, so here we go. Now my probabilities are going to stay the same. I'm just going to change this to B, change this to B. My probabilities are going to stay the same. It's the returns that change. So I'm just going to go through and erase the returns. And why do the probabilities stay the same? It's the same states of the economy. Okay, what is the return of Slowpoke in depression? Yeah. And what is the return in a recession? 0.05. Yeah, 0.05, thank you. And what is the return in normal times? 0.20. And then over here, it's negative 0.05. Okay, now, here's some easy math tricks for you. First of all, what's this? 0. Do I need to put in my calculator at all? No. And notice that this is negative, this positive. It's the same thing, right? So what happens to those? Cancel out. So what's truly the only thing I need to put in my calculator here? 0.2 times 0.5, and when I do, I get 0.10, which is the expected return for Slowpoke, as they say on the slide. Any questions? Okay, now we've got that expected return, and we're going to use that thing just like we did the average return when we were back in the previous chapter. And so what we're going to do is from each return in a state of the economy, we're going to subtract the expected return to come up for the deviation from that return in every state of the economy. And so let's start up here with SuperTech. We know that SuperTech has a return in that state of minus 0.3. We're going to subtract the expected return, which is minus 0.15. Minus 0.3 minus 0.15 gives us minus 0.45. Does that make sense? You can put it in your calculator if you don't believe me. Minus 0.3 minus 0.15 gives us minus 0.45. Okay, now the next step is going to be identical to what we did in the previous chapter, and that is we are going to square the deviation. And when I square 0.45, I get 0.2025. What happened to the negative? Yeah, it goes away because a negative times a negative is a positive. And so that gives me the squared deviation for that state of the economy. Now, here is a new thing. Instead of adding up those squared deviations and then dividing them by n minus 1, now what we're going to do is take the squared deviation multiplied by the probability that that deviation exists. And so for here, it would be 0.10 multiplied by 0.2025 gives us 0.02025. Now, I'll work through this on the calculator when we get done here, so you get another chance to see it, but I'm going to walk you through it first. Okay, now the next one, minus 0.1 minus 0.15 gives me minus 0.25. I square that, I get 0.0625. What's the next step? Multiply by what? 0.2. Yeah, the probability, which is 0.2, which gives me 0.0125. Then we have 0.20 minus 0.15 gives me 0.05. What do I do with that next? Square it. And so now we have 0.0025. And I'm going to multiply that by something. What am I going to multiply it by? 0.5. And when I do that, I get 0.00125. The most common mistake students make on this is they stop at 5. The column 5, and they don't worry about multiplying by the probability, and of course they're going to get the wrong answer. Let's see, finally we have 0.5 minus 0.15 gives us 0.35. You square that, it gives you 0.1225. Then we multiply by the probability, and it gives me 0.0245. Now, all those things in the right-hand column, when we add them up, that gives us variance. We don't have to divide by n minus 1 or anything like that. We took care of that with the probabilities. And we don't have to worry about that minus 1 degree of freedom stuff because we're dealing with population stuff here, population level stuff. How do I know? What do the probabilities add up to? 1. Do we have every possible scenario covered? Yes. Okay, now, would you like to see the easy way to do this in your calculator? Okay. Oh, by the way, you cannot use the statistics mode on your calculator to do this, but I will show you the easiest way possible. So, 0.3 negative minus 0.15 equals negative 0.45. Feel free to play along at home there. Okay, now what should I do next? Square it. Very good. You hit the square button. That gives me this number right here. What is my next step? Yeah, multiply it by the probability, 0.1 equals. And that equals this thing over here. And what I want you to do right now is hit store 1. And if you've forgotten where store is, it's that button that says stow next to 4. Store 1. And you'll see why we're doing that here in a minute. Now we're going to say 0.1 negative minus 0.15 equals negative 0.25. What do I do next? Square it. And then, what do I multiply by? 0.2, the probability. And that gives, come on. Oh, you rascal. Okay. 0.25 squared times 0.2 equals, that's not right, 0.1 negative minus 0.15 equals squared times 0.2. There we go. What do you think we should do with this number? Yeah, store location 2. Clear. Here we have 0.2 minus 0.05. What's next? Oh, sorry, not 0.05. 15, right? What's next? Square it. And what are we going to multiply that by? Yep, 0.5. Store 3. And finally, we have 0.5 minus what? 0.15 equals, and what are we going to do next? Square it, and then multiply by what? 0.2, the probability. And what do you think I want to do with that number? Oh, come on, we've stored 1, 2, and 3. Store 4, right? Okay, how am I going to add all those numbers together that I have stored? Yeah, recall 1 plus, recall 2 plus, recall 3 plus, recall 4 equals. And that gives me the variance of 0.0585. Now, if I were to ask you to go one step further and give me the standard deviation, what would you do next? Yeah, hit square root. And go ahead and write down 0.2419 or 24.19% as our standard deviation for SuperTech. 0.2419, 24.19%. Okay, now let's look at Slowpoke. We won't walk through, we'll just do it in the calculator. We know the expected return is 10%. We figured that out earlier. So I'm going to take 0 minus 0.1 equal, what do I do next? Square it, very good. Multiply by what?
0.1.
Yeah, 0.1, which is the probability of the depression. And that gives us 0.001. What do you think I want to do with this number? Yeah, store 1. Store 1. Clear. Then we have 0.05 minus 0.1 equal negative 0.05. What's next? Square. Multiplied by what? 0.2, right? And then what are we going to do? Store 2, very good. And then we have 0.2 minus 0.1 equals 0.1. What are we going to do with that number? Square it. Multiplied by what? 0.5, very good, thank you. That gives me 0.005. What should I do with that number?
Store it.
Store it where? 3, very good. And then finally we have 0.05 negative minus 0.10 equal, that's this right here. What do we do next? Square it, very good. And multiply by what?
0.2.
0.2, very good, thank you. And what should I do with that number? Store 4. Okay, how do I get this variance? Oh, come on. Recall 1 plus recall 2 plus recall 3 plus recall 4 equals. Okay, there we go. 0.011 is our variance. Now, if I were to ask you to give me the standard deviation, what would you do next? Square root, very good. So go ahead and write down that this one has a standard deviation of 0.1049 or 10.49%. Now when we compare those standard deviations, the first one was 24 point something and this one is 10 point something. Can you tell me which one of those stocks is riskier? Which one's riskier? Yeah, super tech, it's riskier. We know that stocks with higher standard deviations of returns are riskier. And we know that riskier stocks must have higher returns. Does it have a higher return? Yes. Okay, so now we have figured out how to do all the math on here, and I have shown you the quickest, easiest, safest, and most precise way to calculate the standard deviation for both of these things. Did I write any numbers down? No. Did I work columns or rows? Yeah, work it by the row. Work it by the row. Use the store function on your calculator and the recall function. That's the magic. Questions? Okay, now so far we haven't introduced any new statistical terms. We've just been dealing with standard deviation and variance, that sort of stuff. But now we're going to talk about covariance and correlation. Both of these measures have to do with how things move with respect to each other, which wasn't important before when we're only looking at one stock at a time. But when you start putting different stuff into your portfolio together, then it becomes important. So how do we figure out the covariance? Well, it turns out that covariance is very similar to variance. In fact, variance is a special case of covariance. Variance says, how do the movements of this stock compare to its own movements? And so that's why in those cases we had both of these columns of deviations from expected returns being, for instance, for SuperTech, negative 0.45, and how they end up being squared. But now that we're looking at these things and how they move together, what we need to do is look at each scenario and see how these things move with respect to each other in each scenario. And so now what we've got here are the two columns of deviations right next to each other. So we can see that SuperTech, negative 0.45, at the same time Slowpoke, negative 0.10. They're both going down. Are they moving in the same direction? Down is the same direction, right? Okay, now we also have, and by the way, when we multiply those two things together, notice the product of the deviations is positive. Anytime these things are moving in the same direction, whether it's down or up, the product of the deviations, which by the way just means multiplying them together, that product's always going to be positive. But if they're moving in opposite directions, such as they are during boom times, that product of deviation is going to have a negative sign, means they're moving in opposite directions. And so through three of the scenarios that we're talking about here, these things move together. In one scenario, they move in the opposite direction. Now, notice that this product of deviations, when I add all that together, so I've got some negative stuff there. I can't do what I did with it previously. In fact, if we just added the product of all those deviations together, it's entirely possible we'd have something that was negative. Can you take the square root of a negative? No. So, and actually, it's what the next one over that's going to give us that problem. So, what we did in order to find the variance previously is we took the probability times the squared deviation, which has now been replaced by a product of deviations, and that gives us the last column. And now we're going to add up all that last column, and it's going to give us what's called the covariance. And we'll work through this on the calculator in a second. Don't worry. But here's what you need to know. If the covariance is positive, it means the tendency is for these things to move with respect to each other positively. If it's negative, it means they're probably moving in opposite directions. And so even though only one state of the economy here produces a negative product of deviations, when we add up all this product of probabilities and deviations, we end up with a negative number. Now, here's the problem. Remember, we said that we can't really do a good job of interpreting variance because it's percent squared, right? Oh my goodness, check out this thing. It's got the units of percent squared and it's negative. Can you throw the square root on it? Absolutely not. You're getting up with an imaginary number, which we don't teach in business school. Okay, so what are we going to do? Well, it turns out that we are going to then convert this covariance into something called correlation. And the formula for doing that is down on the bottom. Covariance of R sub A with R sub B, that's return on A with return on B, divided by the standard deviation of returns for A times the standard deviation of returns for B. We will do all this math here momentarily. But I want to walk you through how we end up with that negative 0.01. So go ahead and get your calculator out. Hit clear. 0.45 times 0.1. Why am I not bothering to put in the negatives? Yeah, they're going away anyway, right? And I'm going to multiply by the probability 0.1. That gives me this number over here. What should I do next? Store 1. Clear. 0.25 times 0.05 equals 0.0125. What do I do next? Multiply by 0.2. Very good. And what should I do with that number?
Store 2.
Very good. Store 2. Okay, 0.05 times 0.1 equal 0.005. What do I multiply that by?
0.5.
0.5. And what do I do with that number?
Store 3.
Very good. Store 3. And finally, I have 0.35 times 0.15 negative. Why do I have to put the negative in this time?
Because your answer is negative.
Yeah, because they're mixed signs, right? We've got a positive and a negative. And so now we're going to multiply by what?
0.2.
0.2. And that's going to give us negative 0.0105. What do I do next? Store 4. How do I find the covariance? Yep, add them up. Recall 1 plus, recall 2 plus, recall 3 plus, recall 4 equals negative 0.001. Okay, now once again, we don't know how to interpret that, but we're going to convert it into this thing called correlation. Let's go ahead and do that and get the number, and then we can talk about what that number means. And so we've already got covariance in our calculator. We're going to divide by, open parentheses, what was the standard deviation of A? Remember, I had you write it down, 0.24 what? 19, very good. Now, we've lost some digits here, but this is for demonstration purposes only. Times, what is the standard deviation of B? 0.10 what? 49, thank you. Close parentheses, equal. I'm getting negative 0.039. Now you say, wait a minute, how does that help us? Well, it has to do with the units. Remember that the units of covariance are percent squared. What are the units of standard deviation? Mr. Scarborough, what are the units of standard deviation when we're talking about returns?
They're variance squared.
No, they're the square root of variance.
Excuse me, yes.
Yeah. So so if variance then is percent squared, what would standard deviation be if we take the square root of it? It's just straight up percent, man. What if I take the square root of x squared and just get x, right? Okay, so standard deviation down here on the bottom has units of percent. So on the top, I've got percent squared. On the bottom, I've got percent times percent, and that comes out to be percent squared. And so all the units cancel out. And you say, well, good job, jerk. You got us from something that has units to something that has no units. And you'd be absolutely right, except for one thing. We know one more thing about correlation that makes this usable. And that is that it is unitless and that it ranges from -1 to 1. Oh, actually, I don't even want to use the arrowheads on this thing, because after all, this thing is bounded. +1, -1. And then in the middle is 0. And so now we can put up our correlation on this number line and see where it falls. Where would -0.039 fall on this line? Would it be closer to here or here? Yeah, it's closer to 0. So it's like only about 4% of the way over. So we're looking right here at -0.39 negative. Now when I show it to you that way, do we say, do these things tend to move together in the opposite directions, or do they tend to be more unrelated? Yeah, they tend to be a little unrelated. So in fact, what we're going to see, this is called perfect negative correlation. We'll explain what that means in a minute. 0 means uncorrelated, and +1 means perfectly positively correlated. Okay. Now, that's why correlation is easy to interpret, because of this bounding. And if you hear someone say, oh yeah, those things have a correlation of 2, the correct response is, dumbass, it's not possible. Or if they tell you it's -3, you say, moron, right? It's not possible. -1 to 1, that's the entire universe of possible outcomes for correlation. Questions? That's not true for covariance. Covariance could be anything on the entire number line. Okay, so here we have some cool pictures, but I will also do an interpretive dance. So here we go. If two things are moving perfectly together, so in other words, the returns match, then what you're going to see is that they have perfect positive correlation. But it doesn't just have to be matching returns. What about if I've got one stock that goes up by 1, and then the other one goes up by 3, and then this one goes down by 1, and this one goes down by 3? As long as I can take the movements of one, divide it by the movements of the other, and come up with the same positive number over and over and over again, then they are perfectly positively correlated. So in my case, +1 divided by 3 is 1/3. -1 divided by -3 is 1/3. We're always going to get that same positive number. So if this one now goes up 2%, this one goes up 6%, that is still a 1 to 3 ratio. Does that make sense? Okay. Now let's talk about perfect negative correlation. If I have two stocks that their returns are just a pure mirror image of each other, so it's just multiplying one by -1 will give you the returns of the other, they're said to be perfectly negatively correlated. But once again, they don't have to be exact mirror images. What they have to be is the ratio has to be the same. So let's talk about one that we've got a stock here that goes up by 1, this one goes down by 4. And this stock goes down by 1, this one goes up by 4. This one goes up by 2, this one goes down by 8. In each one of those cases, I can take the first one divided by the second one and come up with -1/4. If I can divide one by the other and come up with the same negative number over and over and over again, it means they are perfectly negatively correlated. So we've covered the top two there. And then down at the bottom, there's 0 correlation. And zero correlation says that the return of one has not one thing to do with the other one. They're totally unrelated. The returns on the S&P 500 and the annual butter output of Denmark. Probably not related. If they are, it's just purely by accident, right? And so you're going to see there are lots of things in this world that we can find small correlations on them, but they're truly, really unrelated. Okay. Any questions so far? Okay. So we are going to find, of course, everything in finance, we're wanting to find the return and the standard deviation. And now we're going to try to find the return on a portfolio of stocks. And it just happens to be our two stocks, SuperTech and Slowpoke. And they're telling us that it's a $100 portfolio with $60 worth of SuperTech and $40 worth of Slowpoke. Now, if I told you those were the only stocks in the portfolio, would I have to tell you that it's a $100 portfolio? How would you find that $100? Yeah, you just add 60 and 40 and you're there. In fact, most of the time I will not tell you it's a $100 portfolio. Okay, now the expected return on the portfolio is simply the weighted average of the returns on its components. What is a weighted average? That's the weight. Let's go I to J, because there could be, no, I. Let's do I. Wow, I'm really messing this up. Okay, I equal 1 to I. Whew, there we go. No, that's not it. N. You can tell I had a 3-day weekend. Okay, back to the story. So what I've got to do is for every stock in there, I've got to figure out what is the weight, and in fact, it's going to be an expected return over here because we don't know these returns with certainty. Okay, so now first thing we've got to do is figure out the portfolio weight of A and the portfolio weight of B. And whoever it is that's yawning and sighing over here, you're killing me. You're bringing me down. You're harshing my melon. Stop that. Okay, so portfolio weight of A is just 60 divided by 100. Why do we divide by 100? Yeah, that's the total size of the portfolio. So we've got the market value of that stock in our portfolio divided by the market value of the total portfolio, which we got by adding all the stocks together. And then we're going to find the weight. Oh, now you're yawning. It's freaking contagious. Okay, now we're going to find the portfolio weight of B, and that is, I'm going to take that $40 worth of B, divide by 100, and that gives me a weight on B of 0.4. Now, by the way, all my portfolio weights, what do you think they have to add up to be?
1.
Yeah, got to add to 1 or you've done something wrong, so it's a good way to check your work. Okay, now what we're going to do is figure out this expected return on the portfolio. And we only have 2 stocks here, so in this case, N is going to be 2. And what we're taking is the weight on A times the expected return on A plus the weight on B times the expected return on B. Weight on A is 0.6 times 15% is the expected return. Weight on B is 0.4 times the expected return on that stock is 10%. If you do the math, that comes up with 9% plus 4% gives us 13%. So, the return on a portfolio is simply the weighted average of the expected returns of the individual items in the portfolio. The expected return on a portfolio is simply the weighted average of the individual items returns that are in the portfolio. Okay, Now, remember we got our expected return A and B through population statistics. But let's say you're working with historical data. You could actually find the historical average return and use that as your expected return when you're doing these portfolio calculations. Then the only question is, how far back do I go? If I only go back a few days in the stock market right now, as of the time we're recording this, we're looking at negative returns, right? What if we go back 5 years? We're probably looking at positive returns. And so you end up with a question of how far back do you go? But of course, that's a question we'll talk about later. Now we get to the other part. And we said we were looking for the standard deviation of the portfolio. Well, we can't hit it directly. We've got to figure out the variance. And then to get from variance, we're going to take the square root, and that gets us to the standard deviation. And we're going to start with the simplest case whatsoever, and that is the variance of a 2-asset portfolio, this one we've been looking at. And it is as follows. The weight on stock A times the variance of A. By the way, that sigma squared A is the variance of A. Sigma sub A would be the standard deviation. Plus the weight on B squared times the variance on B plus 2 weight on A times weight on B times, and that last thing you see there is the covariance of A with B. The covariance of A with B. And we've also figured that out on that last slide that had all the numbers on it. We figured covariance. Okay, whew. Now I can plug these things in. I know the weight on A is 0.6. And I'm going to square that. I also know that the variance on A is 0.0585. That is that's 24 point whatever squared, right? And then we're going to multiply that by, and add 0.4 squared times the variance on B, which we also calculated, plus 2 times 0.6 times 0.4 times negative 0.001, which is the covariance of A with B. And when we do all that, we come out with our variance being 0.02234. How do I get to standard deviation from there? Take the square root. And when we do, we get to 0.1495 or 14.95%. Now, I want you to notice we've got these two stocks in here. One of them's got a standard deviation of 24.19%. The other one's got a standard deviation of 10.49%. And so if you're just thinking simplistically, you might assume that the standard deviation of the portfolio would fall between those two. And in this case, it does. But I'm going to show you something amazing. It doesn't have to be that way. Mr. Kunkel, wake up. Thank you. Yeah, apparently you guys just partied all weekend long. Can't say that I blame you. You're young. Enjoy yourselves. Back to the story. Now, the question is, wait a minute, the return on a portfolio was just the weighted average. Couldn't we just do the weighted average, the standard deviations of the items in the portfolio and come out with the same number? Well, let's give that a shot. We could take 0.6 times the standard deviation of A, which was that long number there, plus 0.4 times the standard deviation of B, which is that long number there. And when we put that together, we get 18.71%. Remember, when we just got through doing that calculation for variance of a portfolio, it actually came out to 14.95%, which is less than this 18.71%. So the question that we're left with is, why is the standard deviation on the portfolio lower than the weighted average standard deviations? And the answer is magic. The answer is diversification. The answer is diversification. This is the diversification benefit. Here's the idea. Adding any asset with less than perfect positive correlation with a portfolio to that portfolio eliminates some risk without eliminating return. You still get the weighted average of the return of the items in the portfolio, but you don't get the weighted average of the risk. You get something less. Now, I want you to notice here that it doesn't have to be negative correlation. It just has to be less than positive perfect correlation. And we'll demonstrate that here in a moment. But here's the really outstanding and beautiful thing. How likely would it be that you would find two stocks or a stock that was perfectly positively correlated with your existing portfolio? It's impossible. So for the longest time, Royal Dutch Shell was two firms kind of sandwiched together. One was in the UK, one was in Amsterdam, I think. And so they traded on two different stock markets, but they had both access to exactly the same cash flows under exactly the same tax regime, because at the time Britain was part of the EU. Everything was the same. However, the returns for those two stocks, which should have been perfectly positively correlated based on the fundamentals, were not. Now, they were highly correlated, but they were not perfectly positively correlated. And so if two different shares for the identical same company have less than perfect positive correlation, that means probably you're going to be able to go out there and grab any stock you like and throw it into your portfolio and get some additional diversification benefit. That's some amazing news. We can get rid of risk without giving up return. It's called having your cake and eating it too. If you're an American, you probably know what that means. If not, ask an American friend. Okay, so how am I going to prove this to you, though? That they don't have to be negative? We're going to rewrite that equation. And the first thing that we're going to do is that covariance of A with B, we got to do something with that. And we're going to turn it into something that's in terms of correlation. And so I take the formula for correlation of A with B, which is that rho is equal to the covariance of A with B divided by standard deviation of B to A times standard deviation of B. We've already talked about that. I'm going to rearrange that formula. I'm going to multiply both sides by standard deviation of A with standard deviation and standard deviation of B. And that's going to give me that the covariance of A with B is equal to the correlation of A with B times the standard deviation of A times the standard deviation of B. And now we're going to substitute that back in, because the substitution principle says as long as two things are equal, I can substitute one part in for the other. And so I'm going to take that covariance of A with B at the top. Instead, I'm going to stick in correlation of A with B times standard deviation of A times standard deviation of B. By the way, formulas that I put on the slides, do you think they're good for your note sheet? Oh yeah. So, what if the correlation were perfectly 1? Well, we can plug in all these numbers that we already know and that we've already talked about, and we can actually come out that the variance of the portfolio would be 18.71%. Do you recognize that number? Have you seen that number before today? It's just the weighted average of the standard deviations of the individual components. And so what we're saying here is if they are perfectly positively correlated, then the risk is the weighted average of the standard deviations of the individual components. But if that thing is anything less than 1, if the correlation is anything less than 1, then we are going to have a standard deviation on the portfolio that is less than the weighted average of those individual components. And so it doesn't have to be negative, it only has to be less than 1. So, good test question. Which is the most helpful item to add to your portfolio? One with a correlation of 1, with a correlation of 0.5, with a correlation of 0, or with a correlation of -1? Looking at this formula, which would be the most helpful? Oh, you actually want it to be as low as possible, right? And so -1 would be the most helpful one to add to your portfolio. But would 0 and 0.5 also help? Absolutely. 1 is the worst possible outcome. Most common wrong answer on that question, 0. Questions?
A couple slides back,
Uh-huh.
I know we used the standard deviation, but we didn't like round it, and we had rounded it previously. Do we need to make sure when we take that first standard deviation to?
Okay, very good. I did this for purposes of the slide. Notice when I was putting in the rounded one that I was running out of room. Did you see that?
Sure.
Yes. So it was that real long ass one, right? And so I had to kind of shorten it up. For purposes of any calculation in this class, you should always store the number in your calculator and then just use recall. And there are 3 or 4 main reasons to do that. Number one, it avoids you writing it down wrong. It avoids you entering it back wrong. It avoids rounding error. And there was one other we mentioned, I think, last time. But so, what's that?
Lazy.
Laziness. Oh my goodness. Oh, why do people become engineers? We're lazy. Can't we get a robot to do that, right? Get your calculator to do the heavy lifting. And by the way, your calculator doesn't have bad days, does it? It doesn't get distracted by a squirrel running past the window. Use your calculator. Okay, questions? So let's talk about some a real world example here. And that's the diversification benefit in the S&P 500. By the way, how many stocks are in the S&P 500? 500. I've had a class one time where no one could get that one right. That was just sad. Okay, so basically you can think of the S&P 500 as being a portfolio of 500 stocks. Now I want you to notice that the standard deviation, as of the date this slide was made, the standard deviation was 15.89%, which doesn't really tell you a lot until you start looking at some individual stocks below. McDonald's, 17.74, Pfizer, 19.57, Walt Disney, and so forth. And we work our way on down the list until we get to Google. They've got an extraordinarily high standard deviation of returns. Now, what do you think all those companies have in common? They're all actually part of the S&P 500. All those companies are actually part of the S&P 500. And what can you tell me about their standard deviations of returns compared to the S&P 500? They're all higher. They're all higher. Now, I'm not going to stand here and guarantee that every single company in the S&P 500 is going to have a higher standard deviation than 15.89%, but it is actually possible. Write this down because this is an excellent exam question. Are you ready? It is entirely possible for a portfolio. It is entirely possible for a portfolio to have a lower standard deviation of returns. To have a lower standard deviation of returns. To have a lower standard deviation of returns than the safest single item in the portfolio. Than the safest single item in the portfolio. Than the safest single item in the portfolio. And of course, the safest single item in the portfolio is going to have the lowest standard deviation of anything in the portfolio. And so it's entirely possible that every stock in the S&P 500 is going to have a higher standard deviation because of this diversification benefit. For instance, if you had to look at McDonald's and Pfizer, do you think they're perfectly positively correlated? Oh man, we're in a COVID epidemic. I guess I need a Big Mac and a shot. No. I saw a cute shirt the other day. It said, "Don't worry, I've had my 2 shots and a booster." And it was 2 shots of tequila and a mug of beer. Okay, I'm not encouraging that lifestyle, but there you go. Now, that is magic. That is an amazing outcome. Questions?